In the centuries since humans began looking up at the sky, there has been intense excitement and popular interest surrounding all aspects of astronomy. One of the most exciting recent discoveries is how common planets are around other stars. With our ongoing quest of uncovering the cosmic truths behind the universe we live in, various spacecrafts have been sent out to aid our scientific curiosities. One of the most notable missions would be Kepler, that scoured for Earth-sized planets orbiting at least 60% of the stars visible in the night sky. On the exploration of the structure and diversity of planetary systems, what are the most fascinating Earth-sized and smaller planets in or near the habitable zone discovered by Kepler? How will Kepler's findings of planets outside the solar system help us as we continue our search for extraterrestrial life? Hello, and welcome to Discover Space, a channel dedicated to bringing you the most fascinating facts about the cosmos. Be sure to hit the subscribe button to keep up to date as we explore the universe from the smallest particles to the largest galaxies. The Kepler Telescope was built to scour a certain patch in the Milky Way galaxy seeking exoplanets. The exoplanet hunter observed hundreds and thousands of stars during its lifetime, identifying thousands of exoplanets. On March 6, 2009, the Delta II rocket launched from Cape Canaveral, carrying NASA's Kepler Space Telescope. Its job was to scan a fixed patch of sky within our Milky Way galaxy to find planetary systems. With its wide-angle camera, it had the largest primary mirror ever sent into space. Since the year 2000, astronomers have discovered 2,662 new planets orbiting other stars. These exoplanets are unlike anything in our own solar system. The Kepler Space Telescope was launched in to search for Earth-like planets orbiting other stars and monitored 150,000 stars for over 4 years from 2009 to 2013. The exoplanets discovered thus far are quite a diverse bunch. Some orbit so close to their stars they complete one revolution every several days. These worlds have whole hemispheres that are covered in molten rock, have temperatures hot enough to melt iron, and star-facing sides that reach thousands of degrees Fahrenheit. Others the size of Jupiter both orbit not one but 2 stars. If you're standing on the surface of one of these planets, you'll be able to see a binary sunset. Throughout its life, Kepler has made huge steps toward discovering Earth-sized worlds orbiting at a safe distance from their host stars. Known as a habitable zone or Goldilocks Zone, this area is where the temperatures are warm enough for water to condense on their surfaces. Although being in this zone doesn't guarantee the existence of life, the presence of water is significant and the foundation of life as we know it. In September 2019, 2 scientific teams independently announced that they found signs of liquid water in the atmosphere of exoplanet K2-18b, 124 light-years from Earth. K2-18b is 8 times the mass of Earth and 3 times as big. It orbits a main sequence red dwarf star called K2-18. A red dwarf star is the smallest, coolest star, and by far the most common type of star in the Milky Way. According to Kepler's data, astronomers estimate that 6% of red dwarf stars have an Earth-sized planet in the Goldilocks Zone. To find water on the surface of one such planet in the search for potentially habitable alien worlds, K2-18b is also the first exoplanet with water found outside of our solar system. In 2015, NASA's Kepler Space Telescope discovered a planet orbiting the Sun-like star KIC 846285-2. This finding added to the growing list of planets outside the solar system that Kepler had successfully pinpointed with its transit method. Transits occur when the orbit of an exoplanet passes in front of its host star, dimming the stellar light slightly and giving scientists information about the planet's size and orbit. It is challenging to detect exoplanets using this method, as some stars are brighter than others. The diameter of Earth, for example, is 109 times smaller than that of our Sun. Therefore, Earth would have only a minuscule impact on our Sun's output if observed from afar. However, NASA's Kepler Space Telescope was sensitive enough to make such observations in 2014. NASA also announced the discovery of Kepler 18-6f, an exoplanet about half the size of Earth and orbiting a cool, red star in the constellation Cygnus. Because the exoplanet has a stable axial tilt like Earth's and close to Earth gravity, it is likely that Kepler 18-6f also has stability in its temperature, surface features, and seasons. Researchers at Georgia Tech University, along with many other universities around the globe, are exploring data from the Kepler Space Telescope to help better understand this new planet. In recent years, previously rejected Kepler findings, once thought to be planets due to an algorithmic error, are now being re-examined. One such false positive exoplanet is considered a near-Earth-sized planet orbiting the star Kepler 1649c in mid-2020. While combing through the data obtained by Kepler and matching it against observations made by the transit, this newly discovered world, Kepler 1649c, is 10% larger than Earth, closely matching our planet in size. This planet is located 300 light-years from Earth and receives 75% of the incoming sunlight that Earth does. That means the exoplanet's temperature may be similar to our planet's. Yet another planet has been discovered within the habitable zone of a red dwarf star. But before we get too excited, of the 16 planets that have been discovered to lie within their star's habitable zone, only 3 lie within an area where liquid water can exist. These planets are not ideal for life. Some are tidally locked with their parent stars and would have one hemisphere facing the star and be extremely hot, and the other facing away from it, which would be extremely cold. Others are more like a smaller version of Neptune than a larger version of Earth, and these planets are expected to have thick atmospheres, composed mostly of hydrogen in addition to layers of liquid water on top of a rocky core. This might not sound like an ideal place to live, but scientists believe that underground living beings could use the planet's hydrogen in order to survive. If the hydrogen envelope is too thick, the temperature and pressure of the water layer beneath will be too great to support life on top of all of this. Although red dwarf stars tend to be more active than sun-like stars, red dwarf planets are much closer to their stars, and thus may be exposed to higher quantities of damaging ultraviolet radiation than we see here on Earth. This could mean that surface temperatures range between -100 and 116 degrees Fahrenheit or -73 to 47 degrees Celsius, which means they could be colder than Antarctica or hotter than Earth's most blistering deserts. Unfortunately, we lack the technological know-how to explore the composition and atmosphere of these alien worlds. But based on statistical analysis of all the Kepler observations, astronomers have estimated that 1 in 5 stars like the Sun have Earth-like planets about the size of our Earth and a surface temperature conducive to life, provided that about 20% of our galaxy's stars are Sun-like. This comes out to several billion potentially habitable Earth-like planets just in our Milky Way galaxy alone. The Kepler mission, however, had a specific goal: to find potentially habitable planets. In fact, most of the planets discovered by Kepler didn't even come close to meeting that criterion. Some were so-called hot Jupiters, gas giants composed mostly of gases such as hydrogen and helium with a relatively small rocky core that orbits extremely close to their parent stars. Such fascinating examples of gas giants are Koi 5a, which was first flagged by astronomers in 2011 as a potential planet candidate. It was initially overlooked, however, due to the enormous amount of data that Kepler generated and because its parent star had another companion star. However, astronomers noticed that the main Koi 5a star is much larger than our own Sun, making analysis very difficult for them. Initial research into the Koi 5 system determined that it harbored 3 stars, but scientists were still unsure if the planet Koi 5ab existed, or if the 2009 signal had been generated by one of the companion stars. Yet, thanks to additional data from a test satellite, scientists have confirmed the existence of Koi 5ab. The discovery of Koi 5ab is expected to add a lot to our understanding of planetary formation. The types of planets found by Kepler include super-Earths, which are more massive than Earth yet lighter than ice giants like Neptune and Uranus. Some of them are known as lava planets and are likely the remnant cores of evaporated hot Jupiters. Trojan planets have also been found in strange locations and sometimes even as companions to larger planets, but none have been certainly identified. On the 30th of October 2018, after it ran out of fuel, the Kepler Telescope was retired by NASA. The telescope was deactivated with a goodnight command from mission control. Though Kepler is no longer operational, it has made incredible discoveries predicting a near future in which astronomers will use new and advanced telescopes on the ground and in space to more deeply understand Kepler's numerous finds. In particular, one such telescope is already slated to go up into space, and the James Webb Telescope, named for the second NASA administrator, will take a much closer look at some of these Kepler objects of interest, and hopefully will bring us closer to answering the question: are we alone in the universe? As astronomers continue to analyze data collected by Kepler, what more do you think they will find? Let us know your thoughts and comment down below what other cosmic phenomena you'd like to know more about. Thanks for watching this video, and we'll see you again for another space discovery you won't want to miss.